What if I told you engineers can build a highway or railway beneath the ocean without draining a single drop of water? Thousands of cars and trains travel safely under the sea every day. So how do engineers stop billions of tons of water from crashing into these tunnels? The answer is one of the greatest engineering achievements ever created. Building a tunnel under the sea isn't just like digging underground. It's far more dangerous. Above the tunnel sits an enormous weight of seawater. Every meter deeper means even greater water pressure pushing against the tunnel walls. One tiny crack could allow water to rush in at incredible force. If you are fascinated by incredible engineering projects like this, make sure to subscribe and turn on notification. We explore the world's most engineering feats every week. Now, let's see how engineers make the impossible possible. There is the seabed itself. The ground beneath the ocean isn't always solid rock. Engineers often encounter soft clay, loose sand, gravel, and even hidden cavities. Digging through unstable ground can cause collapses before the tunnel is even finished. And there is another problem. Unlike building a bridge, engineers can't simply stop ocean traffic or drain the sea. Massive cargo ships continue sailing overhead. While construction happens dozens of meters below, visibility is also extremely poor. Divers can only work for limited periods, and deep water brings darkness, strong currents, and dangerous condition. Every tunnel must also survive earthquakes, corrosion from salt water, fires, flooding, and decades of constant traffic. So how do engineers overcome all these challenges? The answer depends on the location, the depth of the sea, and the type of ground beneath it. Engineers mainly use 3 different methods to build tunnels beneath the sea. The first method uses one of the largest machines ever built, the tunnel boring machine, or TBM. Imagine a giant rotating steel cylinder, sometimes over 15 meters in diameter. At the front, hundreds of hardened cutting tools slowly grind through rock and soil. As the machine moves forward, conveyor belts carry away the excavated material. Behind the cutter head, enormous hydraulic systems immediately install precast concrete rings. These rings become the permanent tunnel walls, preventing the surrounding ground from collapsing. Rubber seals between each concrete segment create a waterproof barrier, strong enough to resist enormous water pressure. The TBM advances only a few meters each day, but it works with incredible precision, guided by lasers and advanced computer systems. This method is ideal when the tunnel passes through solid ground beneath the seabed. But what if the water isn't too deep? Engineers may choose an entirely different approach. Instead of digging continuously underground, they first build massive concrete tunnel sections in a dry dock. Each section can weigh tens of thousands of tons. When completed, the sections are sealed at both ends and floated across the water like giant ships. Next, workers dredge a trench along the seabed. The floating tunnel sections are carefully lowered into position using powerful cranes, GPS guidance, and cables accurate to just a few centimeters. Once aligned, neighboring sections are connected with special waterproof seals. After every joint is secured, the temporary end walls are removed, creating one continuous tunnel. Finally, the trench is covered with sand, gravel, and protective rock, hiding the tunnel beneath the ocean floor. From above, ships sail normally, never realizing a busy highway or railway lies beneath them. In shallow coastal areas, engineers sometimes use the cut and cover method. They temporarily block off part of the water, using large retaining walls or cofferdams. The water is pumped out, allowing workers to excavate the ground like a normal construction site. After building the tunnel, everything is covered with soil, and the water is allowed to return. Although simple in concept, this method only works where the water is relatively shallow. No matter which construction method is used, safety is always the highest priority. Thousands of sensors continuously monitor movement, pressure, temperature, and even tiny leaks. Powerful ventilation systems remove vehicle exhaust and supply fresh air. Fire-resistant materials help protect the tunnel during emergencies. Huge pumping stations stand ready around the clock to remove any water that enters. Modern tunnels are designed with emergency exits, escape passages, surveillance cameras, communication systems, and backup power supplies to keep travelers safe. Some of the world's greatest underwater tunnels demonstrate just how advanced modern engineering has become. The Channel Tunnel connects the United Kingdom and France beneath the English Channel, stretching about 50 kilometers. It includes one of the longest undersea sections ever built. Millions of passengers and enormous amounts of freight pass through it every year. Japan's Seikan Tunnel runs beneath the Tsugaru Strait. Because Japan experiences frequent earthquakes, the tunnel was designed with exceptional structural strength and advanced safety systems. In Northern Europe, the Øresund Link combines both a bridge and an underwater tunnel. Vehicles travel across a bridge before entering a tunnel beneath the sea. Each project required decades of planning, thousands of engineers, and groundbreaking technology to become reality. The next generation of underwater tunnels could be even more incredible. Engineers are developing smarter tunnel boring machines, powered by artificial intelligence, that can automatically adjust to changing ground condition. New waterproof materials are becoming stronger, lighter, and more resistant to corrosion. Some researchers are even studying floating underwater tunnels, suspended beneath the surface, instead of resting on the seabed. If these futuristic designs become reality, they could make crossings possible where traditional tunnels simply cannot be built. Every time you drive or ride through an underwater tunnel, you're traveling through one of humanity's greatest engineering achievements, a place where thousands of tons of ocean sit just meters above your head, held back by precision, science, and remarkable engineering. If you enjoyed learning how engineers build beneath the ocean, don't forget to subscribe for more incredible engineering mysteries. Also, check our channel for more videos like this.